Have you ever really thought about what's happening right under your feet? I mean, the ground we walk on every single day holds this incredible story, a transformation that takes millions of years, turning dead stone into a bustling, living world. So let's dive into that journey.
So let's start with a really basic question. We all use the words dirt and soil pretty much interchangeably, right? But here's the thing. They are worlds apart. One is just inert, broken down rock, the stuff you'd sweep off your garage floor. The other is a complex ecosystem, the very foundation of life on land. So how in the world does one become the other?
Our story has to begin with rock. It makes sense, right? About 95% of the Earth's crust is rock. It's the raw, primary ingredient for all the soil that will eventually form.
The first character in our story is igneous rock. The name actually comes from the Latin word for fire, which is perfect because these are the original rocks formed when molten magma or lava cools down and gets solid. Think of things like granite or the basalt you see on volcanic islands. That's the planet's bedrock, quite literally.
Next up, we have sedimentary rock. And you gotta know, nature is the ultimate recycler. As those original rocks break down into tiny fragments like sand and silt, they settle down in layers. And over millions of years, immense pressure squishes them together into brand new rocks like sandstone or limestone.
And finally, there's metamorphic rock. This is what happens when you take igneous or sedimentary rocks and put them under some serious heat and pressure, deep inside the earth. They don't quite melt, but they metamorphose. They change into something completely new. It's how limestone becomes marble. It's rock fundamentally transformed by the planet's own power.
All right, so we've got our three types of rock. But to become soil, they can't just sit there. They have to be broken apart. And this is where nature's demolition crew gets to work. That demolition process is called weathering. It is the absolutely crucial first step where massive, solid rocks get physically and chemically torn down into smaller and smaller pieces. This collection of broken down rock is what we call parent material, and it's the raw stuff that soil will eventually be made from.
Now, weathering isn't just one thing. Nope. It's a relentless, three-pronged attack that comes in physical, chemical, and biological forms, and each one plays its own unique role in turning mountains into dust.
And believe me, these forces are powerful. Physical weathering is just brute force. Water gets into a tiny crack, it freezes, it expands by about 9%, and pop, it splits the rock wide open. Chemical weathering is a bit more subtle, like water slowly dissolving away minerals. And biological weathering? That's just life itself, like a tiny tree root that relentlessly pushes its way through solid stone.
Okay, so weathering has done its job. We've gone from solid rock to a pile of mineral fragments, our parent material. But that's still just dirt. To make that amazing leap into living soil, we need to add a few more crucial ingredients to the mix.
So here it is, the perfect recipe for fertile soil. And check this out, because this might surprise you. Half of it isn't solid at all. While 45% is that mineral stuff and 5% is organic, the other 50% is just empty space filled with water and air. And that space is every bit as important as the solids.
Each ingredient has a critical job to do. The minerals give the soil its structure and nutrients. The organic matter, that's the fuel for all the microorganisms. Water acts like a transport system, moving nutrients around. And air, well, it provides the oxygen so the roots and all the other little organisms can breathe.
Over thousands of years, as these ingredients all mix and settle, and as climate and living things do their work, something really amazing happens. The soil starts to organize itself. It actually develops a structure, a kind of biography written in distinct layers that tells the entire story of its creation.
So if you were to go out and dig a deep trench, you wouldn't just see a uniform pile of brown stuff. You'd see what's called a soil profile, a cross-section showing these different layers, which scientists call horizons. And each horizon has its own unique color, its own texture, and its own chemical makeup.
Let's build a profile from the bottom up, literally. Way down at the base, you have the R horizon. That's the unweathered, solid bedrock we started this whole story with. Right above that is the C horizon, which is made of that parent material, the bigger, broken chunks of rock that have been weathered down but haven't really become true soil yet. As we move up, we get to the real heart of the soil. The B horizon, or subsoil, is where minerals that wash down from above tend to pile up. It's usually pretty dense and rich in clay. But above that is the all-important A horizon, the topsoil. This is that dark,
fertile, beautiful layer that's full of organic matter, where most of the plant roots and soil life love to hang out.
And sitting right at the very top, we find the O horizon. This is the organic layer, made up of all the fallen leaves, twigs, and other decomposing life. It's this vibrant connection between the soil below and the world above, and it's constantly feeding that topsoil with new organic matter.
And the difference between these layers is it's night and day. The topsoil is dark and teeming with life because it's so rich in organic material and has plenty of air. The subsoil, on the other hand, is lighter in color, way denser, and a lot less fertile. And this is exactly why protecting our topsoil is so incredibly critical for, well, everything. So we've taken this whole journey from a lifeless chunk of granite all the way to a complex living system. But why is this process so critical? I mean, why does it really matter to us? To put it simply, soil is the foundation of nearly all life on land. It's not just dirt. It's this dynamic, living system that grows our food, filters our water, and recycles all the essential nutrients. It's easily one of the most vital and maybe most overlooked resources on the entire planet.
So I'll just leave you with this. This whole journey from rock to life is unbelievably slow. It can take hundreds, sometimes thousands of years to form just one single inch of fertile topsoil. Knowing that, it kind of makes you reconsider the value of the ground we're all standing on right now, doesn't it?